In the final weeks of 2025, something moved through our solar system that shouldn't exist. Not a comet, not an asteroid, something else entirely. For 72 hours, observatories across 7 continents tracked an object designated 3I Atlas as it screamed past the sun at impossible angles, defying every predictive model we had. Then, just as suddenly as it appeared, it began its journey back into the infinite dark. But the data it left behind has fundamentally changed what we thought we knew about the universe. This is the story of humanity's first confirmed encounter with something truly alien, and the unsettling questions it raises about what else might be out there, watching, waiting, moving through the cosmic ocean that surrounds us all. December 2025. The Pan-STARRS Observatory in Hawaii captures something unusual. A faint point of light moving against the stellar background in a way that immediately triggers automated alerts. Within hours, telescopes worldwide swing toward the same coordinates, and what they find defies immediate classification. The object is small, roughly 300 meters across, but its trajectory is all wrong. It's not following the elliptical path of something born in our solar system. Instead, it's moving on a hyperbolic trajectory, meaning it came from somewhere beyond Neptune's orbit, beyond the Kuiper Belt, beyond the gravitational influence of our Sun entirely. This is an interstellar visitor, only the third ever detected after Oumuamua and Borisov. But unlike those previous visitors, 3I Atlas is heading inward, straight toward the Sun, on a collision course with the most extreme environment in our cosmic neighborhood. Scientists scramble to gather every possible observation before the object makes its closest approach, because once it whips around our star and accelerates back into deep space, we may never get another chance. The name comes quickly. 3I for Third Interstellar, Atlas from the survey system that first caught it. But names are just labels. What matters is what this thing actually is, and where it came from. January 4th, 2026. Perihelion. The moment 3I Atlas passes within 13 million kilometers of the Sun's surface, closer than Mercury ever ventures, into a realm where temperatures exceed 1,000 degrees Celsius and solar radiation can vaporize solid rock. Every available solar observatory locks onto the target. Space-based telescopes, spectrometers, radio dishes, all pointed at this tiny interloper as it plunges into hell itself. The data streams back in real time, and immediately something becomes clear. 3I Atlas is not behaving like any comet we've ever observed. Comets near the Sun develop brilliant tails as their ices sublimate into space, creating those iconic cosmic brushstrokes across the sky. But Atlas shows almost no outgassing, no significant coma, no tail. Spectroscopic analysis detects trace emissions, water vapor, carbon compounds, but nowhere near the levels expected from an icy body under such extreme thermal stress. Its albedo, the percentage of light it reflects, is unusually low, almost as if the surface is designed to absorb radiation rather than reflect it. Temperature readings are inconsistent, with some areas heating as expected, while others remain curiously cool, suggesting either significant compositional variation or something else, something regulating heat distribution in ways natural objects don't. And then there's the rotation. Most asteroids and comets tumble chaotically through space, their spin the result of billions of years of collisions and gravitational interactions. Atlas rotates with an almost metronomic precision, one full rotation every 11.3 hours, consistent to within milliseconds throughout its entire observed passage. The object survives its solar encounter intact, accelerating as it swings around our star, using the sun's gravity like a cosmic slingshot. But instead of fragmenting or showing signs of thermal damage, it emerges apparently unchanged, now headed back toward interstellar space at over 90 kilometers per second. When you point enough instruments at something for long enough, you start to see patterns. And the patterns emerging from 3I Atlas don't match anything in our catalog of solar system objects. The spectroscopic signature suggests a surface rich in carbon compounds, possibly organic molecules, not unusual for comets, but the specific ratios are off. There's too much complex carbon, too little volatile ice. It's almost as if the outer layer has been processed, altered in ways that natural radiation and cosmic rays alone can't explain. Radar observations from Arecibo's successor facilities reveal surface features, smooth areas interspersed with rough terrain, geometric patterns that repeat at regular intervals. Natural weathering creates randomness. Erosion by micrometeorites over millions of years produces chaos. But some of the features on Atlas suggest regularity, almost like tiles or panels, though resolution limits prevent definitive conclusions. The density calculations are perhaps most puzzling. Based on how the object interacts gravitationally with the Sun and inner planets, minute perturbations measured with extraordinary precision, scientists estimate Atlas has a density far lower than solid rock or metal. It's either highly porous, like a cosmic sponge, or it's partially hollow. Both possibilities raise questions. Porous structure could be natural, the result of eons of comet outgassing, leaving behind a Swiss cheese interior. But combined with everything else, the unusual orbit, the controlled rotation, the thermal anomalies, hollow begins to sound less impossible. One researcher, speaking off the record, describes it this way. Imagine someone handed you a smartphone, but you'd never seen technology before. You might recognize silicon, metal, glass, all natural materials. You might even convince yourself it's just an unusually shaped rock. But once you start examining how those materials are arranged, their precise geometries, their unexpected densities, you'd begin to suspect it was made, not found. Not everyone agrees. The scientific community remains divided, and the debate intensifies as more data becomes available. Tracing Atlas's trajectory backward through space and time is like following a ghost's footprints through fog. You can approximate, but certainty remains elusive. The hyperbolic orbit tells us it came from beyond, but from where exactly? Computer models run the math backward, accounting for the gravitational influence of every planet, every known stellar mass within 1,000 light-years. The results point toward a region of space in the constellation Lyra, roughly 600 light-years away. But that's a volume of space containing thousands of stars, and the margins of error span dozens of light-years. Could it have originated from a planetary system around one of those stars? Possibly. Could it be debris from some cosmic catastrophe, a planet torn apart by tidal forces or blown apart by a stellar cataclysm? Also possible. Or could it be something else entirely? A probe? A derelict ship? A message in a bottle sent by a civilization we can't even imagine? The mathematics of interstellar travel are brutal. To cross the distance between stars takes immense time, even at the speeds we're observing. If Atlas left its home system 600 years ago, traveling at its current velocity, it would have departed around the year 1425 by Earth's calendar. If it's been traveling for thousands of years, or tens of thousands, its point of origin could be a star that's since died, a civilization that's since vanished. Or perhaps it's not ancient at all. Perhaps it was launched recently, accelerated by technologies we can't detect, now coasting on momentum through the interstellar medium. If you wanted to study a solar system, without being noticed, you'd send something small, something that could pass for a natural object, something that could gather data and return home before anyone realized what had happened. The problem with speculation is that it reveals more about us than about the object in question. We see what we want to see, fear what we're predisposed to fear. Science demands evidence, and the evidence for 3I Atlas's origin remains frustratingly incomplete. Let's address the question directly. Could 3I Atlas be artificial? Could it be a probe from another world? The honest answer is, we don't know. But we can examine the evidence objectively. In favor of natural origin, space is full of rocks, icy bodies, fragments of planetary formations scattered across billions of years. The universe has had plenty of time to create every possible variation of asteroid and comet. What seems unusual to us might simply reflect our limited sample size. We've only studied objects from our solar system in detail, a tiny fraction of what exists. In favor of artificial origin, the combination of anomalies. Individually, each strange feature could be explained. Collectively, they form a pattern that's harder to dismiss. The precise rotation, the thermal regulation, the unusual composition, the low density, the geometric surface features. None are definitive proof, but together they create a profile that doesn't comfortably fit our models of natural objects. Some scientists propose a middle ground. Perhaps it's neither wholly natural nor deliberately artificial, but something in between. A fragment of alien technology, yes, but not a functioning probe. Rather, debris from some long-dead civilization's infrastructure. A piece of a space station, a broken solar collector, the hull of an ancient ship, now tumbling through the cosmos as mindlessly as any asteroid. The public imagination, of course, runs wilder. The internet fills with theories ranging from plausible to absurd. Government. Agencies issue carefully worded statements that say everything and nothing. The scientific papers are more measured, but even peer-reviewed journals now contain phrases like "cannot rule out artificial construction" and "warrants further investigation of non-natural hypotheses." What's remarkable is not that we're asking these questions, but that we're asking them seriously, with data to support the inquiry. A decade ago, suggesting an interstellar object might be artificial would have been career suicide. Today, it's legitimate science. Right now, as you listen to these words, 3I Atlas is beyond Mars's orbit and accelerating. Every day, it travels 77 million kilometers farther from the Sun, from Earth, from any hope of further study. Our most powerful telescopes can still track it, but the signal weakens daily. Within months, it will fade from detection entirely, becoming once again just another invisible traveler in the vast dark between stars. The data we've collected represents humanity's entire knowledge of this object. Thousands of images, spectroscopic measurements, radar profiles, thermal maps. Teams of scientists will spend years analyzing every byte, searching for patterns we missed, explanations we overlooked. But some opportunities are lost forever. We didn't send a probe to intercept it. By the time we detected Atlas, it was already too close, moving too fast, and our spacecraft too slow. We didn't land on it, sample its surface, peer into its possible interior. We watched it from a distance, like astronomers have always watched the cosmos, limited by the speed of light and the tyranny of orbital mechanics. The implications, though, extend far beyond one object. If 3I Atlas is natural, it teaches us that the universe creates stranger things than we imagined, that our categories and classifications need expansion. If it's artificial, it means we're not alone, have never been alone, and the universe contains minds and purposes beyond our own. Either answer is profound. Either answer changes everything. Space is patient. It doesn't care about our questions, our theories, our desperate need to understand. It simply continues, vast and ancient and indifferent, filled with wonders we'll never witness and mysteries we'll never solve. 3i Atlas came from somewhere, served some purpose, natural or designed, and now returns to the infinite ocean from which it emerged. We had our moment, 72 hours of close observation, and now it's over. The visitor has departed, but it won't be the last. Our detection systems improve every year. Our telescopes grow more sensitive. We're learning to see the invisible, to catch the fleeting, to recognize the strange among the stars. And when the next visitor arrives, because there will be a next one, we'll be ready with better questions, better instruments, and perhaps, finally, better answers. Until then, 3i Atlas moves onward, a silent traveler carrying its secrets back into the dark, leaving us here to wonder, to theorize, and to watch the sky for whatever comes next. The universe is not empty. We know that now, and we can never unknow it.